So thank you all first to the organizers for this wonderful event. I hope everyone's having a great time. My name is Keith Eidell. I'm a postdoc in the Heman Laboratory right here in the Cook. And it's going to be a two-part talk with my able colleague, Aslı. And the title of my talk today is Meeting at the Cellular Interface, CAR T cells versus B cell cancers. And, we have it there. So I apologize. So patients that come into a clinic and present symptoms of leukemia, this is just a blood smear on your top left side here. And they will present symptoms of leukemia, which includes a number of B cell malignancies that will override in the bone marrow and in the periphery of patients. The first line of treatment is often chemotherapy or cytotoxic drugs. Now, for some patients, they can achieve curative outcomes. But the very real and sad reality is that many patients will sadly undergo something called minimal residual disease, where disease burden goes down, but then over time they will relapse. These patients then become a candidate for a term that you may have heard in the news or here in Kendall Square called CAR T cells or cellular immunotherapy. And what this involves is that we can isolate out of a patient killer cytotoxic T cells. We can express and transduce in them particular chimeric receptors that will identify, target, and kill leukemic B cell malignancies. Then, after generating these cells, we can grow them up and reinfuse them back into a patient where they will travel throughout the patient's entire body, seeking, finding, identifying, and destroying leukemic cancer cells. And just as a schematic here on your left, so we have a T cell that's identifying a unique targeting cancer antigen such as CD19, and then it'll kill through releasing cytotoxic granules into the tumor cell. On your right here, this is a real-time movie of a green CAR T cell utilizing spinning disc confocal microscopy killing a leukemic cancer cell. In our laboratory, we particularly are studying BALL, or B-cell acute lymphoblastic leukemia. And what you're seeing is actually apoptosis or cellular death or membrane blebbing. And one thing I do want to drive home here is that the actions are not from a distance, that the CAR T cell makes firm contact, and it's actually a battle between the receptors and ligands on one membrane versus the other. Now, when we stain for CD19 or a cancer targeting antigen, it's nicely on the surface. If we just take leukemic cancer cells and stain for a targeting antigen, it's nicely on the surface. However, when we add green CAR or engineered green CAR T cells and we mix them at different ratios, what we actually see in blue is our targeting antigen is that these leukemic cancer cells have learned in a cell intrinsic mechanism of internalizing through a process called endocytosis the targeting antigen. Additionally, in this image, depicted also with the yellow arrow, is that the green CAR T cells can physically remove the targeting antigen CD19, rendering the cell an escape mutant. And we also identify in these wells utilizing confocal microscopy that we get these big balls of green cells of CAR T cells that have trogocytosed or physically removed the antigen, and they are stuck together with like one red leukemic cancer cell. And we notice that the green CAR T cells are targeting themselves. So they are either exhausting themselves or killing themselves through a process called fratricide. And this will lead me to our awarded image that my able colleague Aslı will describe what she did.
Good afternoon, everyone. I'm Aslı Gökdemir. I'm a visual designer. I'm embedding visual art into installations with data and science for public art. Thank you to Keith for sharing this meaningful data with me. I'm saying meaningful because it basically shows how human body fights with cancer. I redesigned the colors, tones, and textures to better convey the message of the impactful battle here. By distinctly separating cold and warm tones and focusing on the right hues, I aim to communicate the message effectively. I remodeled the image she took from the light microscope to show texture and depth by using Blender. Blender's features enable thorough detailing and realistic rendering, resulting in a visually compelling representation of the battle against cancer. And also, I aim to center the viewer's attention on the immune cell, vividly portrayed in bright green, symbolizing hope in this image. And circling it, warm tones depict the cancer cells, emphasizing the lumen tweet they pose. So that's how I put my perspective on this work. Thank you.
And I just wanted to add real quick for acknowledgements, all the members of the Heman Laboratory, including my three outstanding Europs, Joey, Hannah, and Anita. Thank you.